So when we talk about domain and range, we're sort of referring to restrictions on a particular function. Okay? We're basically referring to where can the function actually go. If you were to draw up the graph, where in the graph um is sort of the graph going to actually be, right? It's giving us a rough idea of that. Okay? So we know a function is defined as fx or gx or hx is equal to, and we've got some sort of mathematical expression, right? So if you recall, when we're graphing any sort of mathematical graph, we use this here, right? And that's called a Cartesian plane, where we've got a y-axis, which is your vertical line here, and you've got an x-axis, which is a horizontal line here, and then you've got your origin, which lies in the middle. Okay. Now, when we refer to domain refers to all the values that x or the input can be. Okay. So basically, we're referring to when you have a function, where across this x-axis is our function going to lie? Is it going to go, from negative infinity all the way to infinity, or is it going to be, in one particular area? Is it going to be from here to here, or is it going to be from here to here? No, that's what the domain of a graph is telling us. The range refers to all the values that fx or the output can be, or in other terms, where in the y-axis our values are going to be. Okay, so where does our output range? Again, our output could just be from 0 to maybe the number 5, or it could be from -5 to 0, or it could be from negative infinity to positive infinity, right? It could be everywhere. Okay, so that's basically what domain and range is telling us. It's basically telling us where in this Cartesian plane, or roughly giving this an idea of where in this Cartesian plane our graph is going to be. And got different types of functions, which have different types of graphs, like fractions, exponentials, parabolas, logarithms. They all have different types of graphs and restrictions, which influence their domain and range. Okay, so if we look at this simple example here, we've got a simple parabolic graph. Okay, now simplest parabola you can have, y is equal to x squared. Now we've got a graph generated of this, and just to be clear, we've got this is our x-axis here, and this is our y-axis here. Okay, now if you look at the domain and range for this one, if you think about it realistically, the domain, again, remember we're referring to the x value, right? So is there any restriction that can be there in x? If we're squaring something, is there any number that we can't square? And the answer is no, right? There's nothing that we can't really square. Okay, you can square negative numbers, you can square positive numbers, you can square the number 0, you can square decimals, you can square fractions. Anything can be squared. Okay, and that's why for the domain, we can't see the actual graph because it'll just go on and on and on. But there's no real restriction on the domain. Okay, so this graph, if we're talking about horizontally, it's going to continue forever. Okay, we're up to 10 here. It's going to keep on going this way, and it's going to keep on going this way as well. Okay, there's no restriction. If you talk about y forever, what's something that we can see with the y-axis or with the output? We can see that this graph on the y-axis, it's never going below this point 0. Why is that the case? If you think about it, we know that if you square a number, it always becomes positive because you're multiplying it by itself. So even if, say, the number is negative, so let's say if you have x is -5, if you multiply -5 by itself, you're still going to get a positive number. That's why the y value or the output is all the way up there, and we have nothing in the negative section here. So whilst there's no restriction on the x values, we know that y can never be less than 0. The smallest value can be 0. And that's if you square 0. Okay, but if you square a negative number, if you square a positive number, you're always going to get a positive answer. So if we look at the domain and range for this question, the domain, as you said, is all real values of x, and the range is y has to be greater than or equal to 0. Okay, now when you do learn domain and range, there are a few different notations and a few different methods in which we write or which we annotate how to write the domain and range. But for now, I'm just going to be going through simply how we sort of go about finding the domain and range and what it is. And then we can look at the formal notations in further videos. But for now, if you look at another example, so again, we've got a parabola here. It's the same y is equal to x squared. We've just got a plus 5 at the end of it, okay? Now, we know that with our parabolic transformations, if we've got a constant at the end, that shifts the graph up or down, okay? In this case, we have a positive constant, so it's going to be shifting the graph up 5 units, okay? Now, again, if we look at the domain, there's no real restriction on what x can be. X can still be any number. You can still square any number and add 5 to it, okay? That doesn't change anything. So the domain is still all real values of x. Now for y, again, if you look at a graph, the lowest point now is 5, right? It never goes below 5. And again, we can sort of think of that as if we were to square a number, the smallest value we can get is 0, right? If we just had this y equals x squared, the smallest value we can get is 0. But now since we've got a plus 5 to it, everything shifts up by 5. So even if you're squaring the number 0, we're adding 5 to it. So that means now the smallest value you can get is 5. Right? Even if you now, let's say we have negative 3 here. Negative 3 squared is 9, and then plus 5 is 14. Okay? So you're never going to get any number that's less than 5 again. Why? Because this portion can never be negative. And if this portion, if the smallest value this can be is 0, then the smallest value that this whole graph can take up is 5. So again, if you look at the domain and range, again, the domain is all real values of x, and the range is just y has to be greater than or equal to 5. Okay? Okay, now we've got a sort of different example here. We've got y is equal to the square root of x. Now, if you look at the graph, we can see that now we actually do have some sort of restriction on what this x value can be. Okay? And what is that sort of restriction? What is the restriction with square roots? The restriction, which we all probably know, and we can probably also tell from looking at this graph, is that we can't square root negative numbers, right? So that means that's why this graph as well, it starts from 0, and then it just continues on to the right, wherever. Because a number can be as positive as you want. You can square it up to a million, you can square root up to 1 billion, 1 trillion, 10 trillion. You just can't square a negative number. Okay, so the smallest value that x can be in this case is 0, and it can go into infinity. It just can't be anywhere in the negatives. Now, because of that, there's also a restriction on y here. If you look at the graph, y is also never goes positive, right? It's always in this upper quadrant here, or this upper half of the graph. It is actually only one quadrant. And that's because since you can't square root a negative number, the answer of a square root can never be negative. Okay? So if you look at the graph here as well, and the domain and range, the domain is x has to be greater than or equal to 0, and the range is also y has to be greater than or equal to 0. Okay? Now we'll go through one last example, and now we've got y is equal to the square root of 3x minus 15. Okay? Now again, this is the same sort of concept in the sense that we know we can't square root a negative number. So whatever is inside here, so this 3x minus 15, this cannot be negative. Okay? Now, if 3x minus 15 cannot be negative, that means that 3x has to be greater than or equal to 15. Right? Which means that x has to be greater than or equal to 5. And that's going to be our domain here. That as long as x is greater than 5 or equal to 5, this square root or this equation here will never be negative and will be good to go. And as the same thing for y, since we can't square root a negative number, the answer of a square root can never be negative, so that stays the same. Okay? So again, the domain is x is greater than or equal to 5, and the range is y is greater than or equal to 0. Okay? So the easiest way to sort of do these questions sometimes would just be to graph it out and just have a graphical look. I've shown you that you guys can use your knowledge from functions before It's like you guys know that a problem, if you square a number, it can never be negative. You can't square root a negative number. So knowledge like that can help you find the domain and ranges algebraically as well.